Velocity and other rates of change. Okay, let's recall the instantaneous rate of change of any function with regards to x, at x equals a, is the derivative. Okay? What you mean, basically, is derivative and antiderivatives, yes. Which is funny, because if that's all that it is, we should probably master it. So, yeah. That's all right. That's all right. So, x equals a is the derivative, and you know we can take a limit as int approaches 0. And that's basically just a derivative, okay? We've learned now to use the chain rule, which is cool. All right? So, example. Let's find the rate of change of the area of a circle with respect to its radius, r, when the radius is actually 5. All right? So, right? So the area of a circle is? Right. And how do we know we need area? Because change of the area of a circle. And you told me that the area is pi r squared. So, if I want to find the rate of change, that's what? The derivative, right? That's the rate of change, okay? When I point to it on the video, you guys can say it, don't worry. Fine. Fine. How about this one? Respect. Find respect. Analysis. See, that's analysis. So analysis needs to find some respect for calculus. Oh, I stop! I can't rewind. I'm so sorry. Okay, let's find the rate of change from the area, pi r squared, which means if area equals pi r squared, what is the derivative? Remember, pi is a what? What's pi?
3.14 blah blah blah.
Yeah, it's 3.14. It's a constant. And how do we handle constants when we take the derivative? We take the exponent, multiply it by the constant, right? And then just reduce the exponent by 1. Correct?
Yeah.
So, wait for it. I'm going to take my 2, multiply it out front, and then after I do that, then I take 1 away from my exponent, and that becomes the new exponent. 2 pi r. Reverse. All right? So find the rate of change of the area of a circle with respect to its radius. At where? When r is 5. That's the derivative. That's the average rate of change. It would be instantaneous. They just say rate of change. Yes, it's very nice, sir. Now, you're welcome. You want to find this right x when the radius is 5. So guess what I do? 2 pi. Oh, to make it exact and not round, that is the rate of change for a circle the moment its radius is 5. All right, so if we are given a function that's s of t, that's the position or the distance of a moving object, because derivatives also help us in this fashion. And how so? Well, if the original function s of t represents the position of a moving object, if it's moving and I want its exact position at 5 seconds after it starts moving, I just find out 5 and go. I put t as 5. But the velocity, which is v of t, that's the rate of change of position. Okay? And what do we say rate of change is? Slope. It's the derivative. The rate of change is the derivative of something. Isn't that the change in slope, the rate of change? Slope is derivative. All right? So, in order to find the velocity, we find the rate of change of the position. We just take the derivative. of the original function for position, and that will give us the equation to find the velocity. Okay? Now, note, velocity includes an object's speed and direction. If it is negative, that means it'll be going to the left. If it's positive, it's going to the right, like if we were to graph it. Okay? It was to move along an axis. Okay? So, as I just said, velocity is just a derivative of position. And this might seem complicated because they're words, but they might say position is represented by x squared. Well, what represents the velocity then? 2x, which is the derivative of x squared. All right? So, if I take the derivative of the position equation, that's going to be the velocity equation. Just derivative. So yes, a lot of this course, derivatives, and then we'll get to a certain point in it, and then we work backwards from derivatives. Like we'll be given the derivative, we've got to find the original function. That's called antiderivative. Differentiation. So we have S of t is for position, V of t is velocity. What do you think A of t is? Acceleration is right there. That's acceleration. Acceleration is the rate of change of the velocity. So, in layman's terms, what does that mean?
Derivative of the derivative.
Yeah, you take a derivative of the velocity. And the velocity is the derivative of the position. So if I have the position and I take the first derivative, that gives me velocity, right? If I take the second derivative, which is just taking the derivative of the derivative, that gives me acceleration. So, if I take the derivative of velocity, that's acceleration. This also represents the second derivative of position. And you would have been right, sir. Check, check. Therefore, position is your original equation. Velocity is your first derivative, and acceleration is your second derivative. That's it. That's it. Velocity is your first derivative of your original equation, and acceleration is your second derivative. Freefall constants on Earth. This isn't on Mars, this is the moon, because we use gravity here. Other places have gravity, but due to their size, they're different rates. Now, a falling object, starting at rest, will accelerate at the following rates. 32 feet per second, or 9.8 meters per second. Okay? The distance of a falling object starting at rest has this equation right here. Okay? Has this equation right here. But it depends where in the world you are calculating it. Because I think the U.S. is really one of the only places that use feet. A lot of the other countries in the world, metric system. Canada, Europe. And those are really the ones that matter. No, I'm just joking. No, thank you. I would have been really pissed if I were me. Anyways, so if I take this and I throw in my, that's right, that's 1/2 32 times squared, right? So that is 16. Now we used to do free falling and pre-calc or algebra 2. Then we always start with a negative 16t squared because it is a downward direction gravity. That's what would make it negatives. What about here? If we're using metric, which would be 4.9. The distance of a falling object. And of course, when we start using these, we can start figuring out the rate at which they are falling. When we find the rate change in something, we take the derivative of it. Alright? Okay, here. A ball is dropped from the top of a 200-foot building. How long does it take to hit the ground? Well, we should know that if this is in feet, I'm going to use what? 32, right? But when I do that, that is 16t squared. That's going to be the math expression to represent my gravity, okay? So, I'm going to say it is starting at 200 feet, and I'm going to subtract my 16t squared, okay? And that is going to give me time, and that'll give me the height, right? When it hits the ground, it'll have a height of 0, won't it? So, how do I solve for t? Because they want to know how long it takes. Yeah, I could either factor it, but since there's one variable here, t, I can isolate and solve them as one variable like it was with everything else, which is what I would do. Okay? So, I'm going to add 16t squared to both sides. And I've got 200 equals 16t squared. Now I'm going to divide by 16. What do I get? What is 200 divided by 16? I now get 12.5 equals t squared. I want t, not t squared. I take the square root. What is the square root for the nearest hundred? 2 decimal places. What is it? 3.54. Remember, when I take the square root, it's plus or minus. Question. Why do I not want plus or minus here? Yeah, I can't have negative time. I can't have negative time. So it is approximately, because we rounded, 3.54 seconds. So what is the velocity? Well, velocity is just a derivative of our original function, isn't it? Velocity will be what? What's the derivative of that? This goes to 0, this is negative 32t. And after 3 seconds? 96. Yeah, this tells me my t. My time is 3 seconds. Negative 32 times 3, which is negative 96. What's my label? Feet per second. And guess what? You really shouldn't put it in negative 96. You should say it's moving 96 feet per second downward. Okay? So, question. If it takes 3.5 seconds, approximately, to hit the ground again, well, 3 seconds, that's almost, it's another half second with hitting the ground, so that's probably one of its fastest points. All right? All right. A dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second, and it reaches a height of, and here's our equation, position, x equals 160t minus 16t squared after t seconds. How high does it go? So here's a hint. What's the velocity at the high point? If something's going up, and the high point that comes down, what's the velocity right at the top? 0, because it's going positive, and then it has to go negative. It can't switch unless it hits 0 in between. Okay? So when is the velocity equal to 0? Well, velocity is s prime, right? Which is, if I take the derivative of this right here, what is that? 160 minus 32t. I need to figure out when that is equal to 0. So I just solve that normally. Okay? I say I can add 32t to both sides. Yes. So, this goes away. Got 160 equals 32t, and what is the value of t? So, 5 is my time. It's 5 seconds. That's when this velocity is going to be 0, when it's going from up to down. So now that we know this is the time of the high point, how do we figure out the position of the high point? We take this and put it into our position equation, because I know what time the high point's at. It's at 5 seconds. So I can just put my 5 into here and into here. So my position at 5 seconds is the high point. That's 160 times 5 minus 16 times 5 squared. What do we got? That 800 minus 16 times 25, is that 400? So want to check me? Something like that. Thank you for having confidence. It's 400? So guess what? So what is the high point? When does it occur at? 400. And yes, that's feet. 400 feet, because we are using feet per second. What is the velocity when the rock is 256 feet above the ground on the way up, on the way down? All right? So, if this is the position, I'm going to use my position equation. We have 160t minus 16t squared equal to 256. That's the position where I want the velocity. I'm going to bring my 160 and 16 over. Okay? So that would give me 16t squared minus 160 plus 256 equals 0. Is everybody with me there? That's accurate. No, this is my t. Yeah, that's right. Yeah, that's right. See how I did that? Starboard. So, I want to figure out the time, okay? I want to figure out the time first, because remember, once I get time, I can put it into my velocity and figure out speed. At what time? Buddhas? What's the question? Here?
Yeah.
Because I add 16t squared to both sides, so it's positive. That's a legit question. So now, if I know the time that it's at this height, then I can figure out the velocity, correct? Well, I can definitely factor out a 16 first. What does that leave me with? T squared minus 10t. How many times is 16 over 256? 16 plus 16 equals 0. Yeah, because now I can factor in t-bone. What are two numbers that multiply to be a positive 16 that add to a negative 10? Negative 8 and negative 2 equal to 0. And when I t-bone, what are my two times? Time of 8 seconds and a time of 2 seconds. Thank you. I could say 16 equals 0 and it would be nothing. It would be nothing. You guys don't try it here. Okay, so if I... Time does it's called a plus. Not the T, it's a plus.
But
We did. Now, velocity. And this is where we'll end. Okay? What's my velocity equation again? Our velocity is 160 minus 32t, wasn't it? If my velocity is 160 minus 32t, well, I need to find the velocity at 8 seconds and the velocity at 2 seconds. So, it's 160 minus... Are we ready? Can we go on? Are we ready? Yes. 32 times 8. And I've got 160 minus 32 times 2. What are those values going to be? This is going to be negative 96. And what's this one going to be?
Oh, God dang it.
This one's 96. Now wait for it. That means after 2 seconds, if this rock was like this, after 2 seconds, and then at 8 seconds, it is going to be 256 feet after 2 seconds, and after 8 seconds. See that? It's just on the way up and the way down. It's going to be going 96 feet per second on the way up, positive. And after 8 seconds, it is going on the way down, negative. Okay?